Our gut is home to trillions of microbes, and these tiny organisms play a massive role in shaping our immune system from the day we are born to the last years of life. Today, I will talk about how the microbiota interacts with the immune system across the lifespan. We will see how these interactions start at birth, influence immune development, and impact health and disease throughout life. Understanding this connection opens the door to new ways of maintaining health and preventing disease, from diet and lifestyle to microbiome-based therapies. Again, let's look at an overview of how the microbiota and immune system interact throughout the body. The microbiota plays a central role in regulating immune responses at barrier surfaces such as the gut, skin, and lungs. The gut functions as a highly dynamic bioreactor where microbes, metabolites, immune cells, and host tissues interact continuously. These interactions are tightly regulated and influence both local mucosal immunity and systemic immune responses. Importantly, this system maintains a balance between tolerance and inflammation, which is essential for health and disease prevention. With that overview in mind, let's start at the beginning: how microbes shape immunity from birth. Early life represents a critical window during which the microbiota shapes immune development. At birth, microbial colonization begins and drives immune imprinting. This process influences the maturation of immune cells such as T cells, B cells, and innate lymphoid cells. Factors like delivery mode, diet, and antibiotic exposure can alter microbiota composition. These early life interactions have long-term consequences, affecting susceptibility to diseases such as allergies, autoimmunity, and metabolic disorders. Early life microbes shape the immune system, but it is their signals and metabolites that really drive this process. Microbiota regulate immunity through both direct and indirect mechanisms. Directly, microbial-associated molecular patterns such as LPS activate pattern recognition receptors like TLRs and NOD receptors on immune cells. Indirectly, microbial metabolites such as short-chain fatty acids modulate immune responses by promoting anti-inflammatory pathways and maintaining epithelial integrity. Together, these signals help balance immune activation and tolerance, ensuring controlled responses to commensals and pathogens. These microbial cues then influence immune cells and pathways to maintain balance in the gut. Microbiota-derived signals influence multiple immune cell networks. These include epithelial cells, innate lymphoid cells, and adaptive immune cells such as Tregs and Th17 cells. Cytokine pathways involving IL-1, IL-25, IL-33, and IL-13 coordinate these interactions. A key outcome is the promotion of regulatory T cells and suppression of inflammatory responses. This dynamic balance is essential for maintaining mucosal homeostasis and preventing chronic inflammation. Finally, we will see how these interactions affect health over the lifespan and open doors for new therapies. Across the lifespan, the microbiota continues to shape immune function. A balanced microbiota supports immune homeostasis, while dysbiosis can contribute to inflammatory, metabolic, and even cancer-related diseases. Diet plays a major role by influencing microbial composition and metabolite production. Importantly, this understanding has opened new therapeutic avenues, including microbiota-derived molecules, dietary interventions, and microbiome-based therapies aimed at restoring immune balance. Exciting findings reveal the central role of microbiota in immune balance, but they also uncover important gaps that present opportunities for future research. First, we still lack a precise mechanistic understanding of the critical early life imprinting events through which neonatal microbes shape long-term immune trajectories. Second, while microbial metabolites clearly modulate immune function, how specific microbiota-forced metabolic interactions operate at the molecular level is poorly defined. Third, much of the current evidence is systemic, but we need deeper insight into tissue-specific immune programming at distinct barrier sites. Finally, translating these insights into therapeutic strategies such as targeted microbial metabolites or microbiome-based co-therapies requires further work to bridge basic biology and clinical application. Thank you very much for listening to this presentation.